and challenging data sets. Today, we're going to be talking about a topic we hear a lot about these days, which is how to do more with less while elevating your game in data management, delivering innovation across the enterprise, and ultimately new business opportunities and growth. We're thrilled to be joined by the CEO of Intelligent Business Strategies, Mike Ferguson, who is a longtime industry veteran in data warehouse. Mike is going to walk us through some key considerations for how to reduce ETL and data warehousing costs at scale. Mike is an industry analyst and independent consultant who specializes in business intelligence, analytics, and data management. He has over 40 years of IT experience. And after we hear from Mike, we'll also be hearing from Ocient's Chief Product Officer, Joe Jablonski. Quick reminder that we welcome your interaction throughout the presentation. Please say hello and leave a comment on the LinkedIn event page. Let us know where you're tuning in from and feel free to ask a question. We've got our team at Ocient watching the comments to help us moderate. Mike, let's get started. Help us understand the problem with siloed data management environments and runaway costs that we're talking about today.
Okay, thank you, Chris. Let me just share my screen here. Okay, hopefully everybody's seeing that.
Yeah, I can see it. Looks great.
Okay, so many thanks everyone for joining. Good morning, good afternoon, good evening, or wherever you may be, and thanks for taking time out to talk about this. I want to start off by just, let's say, talking about executive expectations around this whole world of data-driven enterprise. And then, kind of zoom in on, well, what's happening amidst all of this data-driven activity that's going on with respect to data engineering, and try and understand the implications of that, particularly to do with overall cost associated with that. And then I'd like to then zoom in on the kind of, well, requirements that if we're going to start dealing with data engineering at a hyperscale level, what kind of requirements would we need to be able to deal with that? So let's just get going. I guess when I look at a lot of my clients as an independent analyst, I have clients all over the world in multiple vertical industries. The expectation amongst C-level executives for data and analytics is sky high right now. It's front and center of almost everything they're doing. And the expectation is that they're going to disrupt the industries that they operate in. It's really going to dramatically transform their business. The fact is that their expectation is also that it's going to speed up their ability to become much more responsive and proactive in the vertical industries within they operate and give them a competitive edge. But if you're going to go do this, you really need a rock solid data foundation. And so if you're going to, you need a rock solid data foundation. And I guess historically, the data foundation in past years was a kind of centralized data warehouse where I guess central IT did pretty well all the data engineering, often with a single technology, a single product data engineering tool of some kind. And that would in doing ingesting, for example, and processing data and transforming it to get it into shape to analyze, and doing that at a data warehouse level or subsets of that down into data mart level for people to access there. But if you look at what's happened amongst the data-driven enterprise in the last few years, we are really gone way beyond the classic structured data, master data, transactional data coming out of internal transaction systems. We're now into all kinds of data feeds, machine-generated data, whether that be industrial IoT and manufacturing, or consumer IoT if you've sold products such as mobile phones or I have even have a new toothbrush, which has got sensors in it, and I have a mobile phone app to tell me how I'm brushing my teeth. I mean, so we get sensors in all kinds of consumer devices nowadays. We've also got you know, devices in cars. We as well emitting data, everything there. We've got clickstream data as people click on websites being logged, all of those clicks being logged. That's an enormous amount of data. We've got log files as people want to investigate things like cybersecurity, looking at infrastructure logs, application logs, network logs, tons of data there. Add to that human generated data, whether that be you know inbound emails from customers, opinions the customers may have about your brand or or specific products or specific aspects of your products, as well as all kinds of competitive news feeds and tons and tons of new external data, free data in some cases from government. If you go in the US to data.org, you'll see about 300,000 data sets free from the US government on pretty well everything going on across the United States. Similarly, in Europe, every country's got the same thing going on. And of course, people buying in data from commercial data providers as well. So all of this pouring into the enterprise. And we've already gone beyond a classic data warehouse per se into multiple analytical workloads, still typically centralized and handling different kinds of use cases, everything from data science to real-time streaming analytics, maybe fraud activity on graph databases as well as classic data warehousing and whatnot. And I guess one of the problems that's emerged as a result of all of that is we've got silos, and so data engineering has expanded into each of those silos, but often different people working in each of those silos to deal with processing data from various sources for those different kinds of analytical systems. I'll come back to the implications of that in a second. But certainly the data just keeps coming, and it's pouring into the enterprise from pretty well everywhere, coming into multiple clouds, could be still coming into on-premises systems like Hadoop systems, for example, or NoSQL databases. And the result is that the complexity is getting greater. And that has a challenge. The expectation I said at the beginning amongst executives is, oh, by the way, we want to speed up and get more agile. And yet the data landscape is becoming increasingly more complex. It's distributed. We've got data in software as a service apps. We've got data on multiple clouds on various systems, whether those are transaction processing oriented or whether they're analytically oriented. We've also got data in on premises and even at the edge. And so with that complexity, makes it harder to find data to be able to manage and integrate it. And so ironically, when we want to see speed and agility, we're getting slowed down by complexity as more and more data sort of spreads out across all the places it's coming into. And therefore putting pressure on data engineers to try and find that. And so, as I said earlier, we've come from a background where most organizations have had centralized IT, data engineers dealing with these kind of centralized systems that we've seen. The problem here is that those folks aren't very familiar with the new data sources coming in, yet they've got no ownership of that data. The number of data sources continues to grow, and the number of users demanding more and more data continues to grow. And so the net result is that, not surprisingly, these guys become a bottleneck. And so we have to do something. Companies are under pressure to do something about that because the expectation is speed and agility, and yet what we now find is that we're being kind of held up by huge amounts of data, greater consumption demand, and not enough resources. And not only that, but within these silos that I spoke about earlier, that we've now got the same data being extracted and transformed in repeatedly sometimes, from the same sources for different analytical use cases. Probably a easier way of showing it is here, sort of different analytical use cases on the right-hand side, data sources on the left-hand side, and pipelines being developed in between. But you can quite clearly see that how many times the same data are going to get extracted and transformed for a different target environment. That it seems to happen repeatedly and potentially inconsistency. And so that's kind of, the combination of that bottleneck that I mentioned, plus that problem of inconsistency, has kind of seen the explosion of data mesh emerge. And to overcome that bottleneck in data engineering and democratize the data engineering um, requirement, so they get far more citizen data engineers, if you like, around the enterprise participating in integrating data and producing something called data products. And of course, the data products, produced by integrating data from these increasing number of data sources that are holding our corporate data. And the idea behind data products is to be able to build shareable, reusable data sets that speed us up going forward. And so ultimately, the difference now, of course, is we've got many more data engineers participating in producing um, these data products. And so therefore, the amount of data engineering as a result of data mesh is going to increase dramatically as more and more people get involved in producing these data products. The idea, build them once and reuse them everywhere. So that means that we're going to see a scale out, if you like, of data engineering around the enterprise. And so we have multiple teams producing data products and building those pipelines that are out there, potentially with a lot of different kinds of tooling. But one of the key aspects of data mesh is the fact that I can publish a data product in a data mesh and then have someone else consume it, which therefore increases the number of pipeline dependencies. So if I'm taking a data product into my pipeline that someone else has built, I'm kind of dependent on these other pipelines. And so not only is the complexity of data growing, but also the number of dependencies is growing. Of course, you can see the advantage of reusing what other people have built, but at the same time, number of pipeline dependencies also increasing.
Hey, Mike, I want to jump in first with a pile-on comment on your good articulation of just this growing hurricane of data volume. And when I've spoken on this topic in the past, I've always basically the underlying thing is every new version of something creates more data than the version it replaces, and there's every example of that. I don't know anything about seismographs, but I do know that the new one makes more data than the old one. I don't know anything about container ships, or you mentioned toothbrushes. And so I guess I'll challenge the chat to name something where the new version makes less data than the old version. Because so far no one really has come up with an example, because everything else makes more data. But I do have a question. As you kind of get into this data mesh and these data products, one of the challenges will be like you're enabling more people to kind of access data. And, one of the kind of tricks that everyone's doing is to kind of filter the data down or put data in intermediate tables or caching things. I mean, how does that affect, ad hoc queries? Doesn't that make it difficult then to kind of go off the script as a citizen data engineer and do some kind of analysis that wasn't anticipated by the IT professionals trying to harness in scope and filter this incoming tsunami of data they all face?
Yeah, absolutely. I mean, temptation's there, right? I mean, more data, therefore all kinds of questions, and you run one query and kicks off another lot of questions in your head, and as you can see, it sort of snowballs from there. So I absolutely agree that not only are we have more people doing data engineering, more pipelines emerging, and people reusing stuff in other pipelines, creating a kind of web, if you like, of all of these pipeline dependencies going on. But at the same time, as more and more people do that, more and more questions pop into their heads. All of a sudden, new versions of these pipelines have to emerge in order to
Right.
get new versions of data products, and the whole thing just, yeah, it's potentially on an exponential growth path here in terms of the amount of stuff that we're potentially generating.
Great stuff. Thanks.
So if you go further than that, you kind of look at what else is going on here in a way, we're also getting more and more of this data. And of course, on-premises systems, perhaps in some cases, maybe they're running out of space or something, but all the temptation is, oh yeah, move it to the cloud, move it to the cloud. That's always the way. Go over there and we'll get the scale as the data volumes grow. Because not only that, but over in the cloud, there's all kinds of public data marketplaces, which, by the way, give you additional data that you're not maybe ingesting or you're not coming into your enterprise currently. But there's a ton of folks out there providing these data marketplaces that have all of this additional external data that you can also get to add to what you already know. And so yet even more data sitting over there that says, well, yeah, you can attempt you over there. And so bottom line here is the volumes are growing and growing exponentially, let alone producing new versions of things, as you just mentioned. Now, as the number of data engineers grows, the volume of data grows, migration to the cloud, you can imagine, of course, the number of tools that are out there offering data engineering capabilities also exploding. And right now, if you just look at this kind of types of data engineering tools that are available in the cloud, they're all there. Everything from classic ETL, data fabric, data virtualization, self-service data prep. We've got tools that just do transformation. We've got data science workbenches for data scientists who want to engineer data for their feature engineering. You've got notebooks, of course, you can write your own code. It just goes on and on and on. So there's a raft of these different options available that people can just subscribe to and use. If we go back to the kind of idea of lots of different citizen data engineers around the enterprise now building pipelines, and there's a range of different tools available to them, what you then begin to realize is I've now got more data engineers building pipelines. I've got the ability to swipe my credit card and go, so therefore, they could quite easily go out and use all kinds of different tools. There's no metadata interchange because the one thing I haven't yet mentioned is there's no standard to share metadata across these tools. So it's often the case that people with one tool don't know what people are doing in other tools because they've got no way of knowing. There's no way to share metadata. And so they're completely unaware of who's building what and potentially may not realize that something's already been built. And so they go and build it again and get a lot of reinvention going on. And the other thing going on, of course, is that every one of these different tools that is out there has probably got a different unit cost associated to, being able to billing for their usage. Um, so if you can imagine that degree of complexity plus all the pipeline dependencies and everything else that I said to you. And by the way, these tools just keep coming. If you just some examples put against those different categories that I saw earlier. So the bottom line, as far as I can see, is that the magnitude of choices is huge. Companies can go and grab whatever they want out there, and of course, with more and more autonomy around business units, people are doing exactly that potentially. And so, you could have many, many different tools involved in developing pipelines, and those pipelines could be, producing something, and so is taken into another pipeline, done in another tool, and so you've got a range of different tools involved, in going, if you like, end to end. And then you add in to the mix the pressure of very large data volumes and vertical industries wanting to deliver in short amounts of time problems like regulatory reporting, which have to be done on a regular basis. You have to do them, but yet larger and larger data volumes, companies still have to operate. They haven't got time necessarily to move everything to the cloud first. That could take quite a while in order to be able to do that before they can produce, they can't wait for all that to happen before they can produce these regulatory reports. let alone, as more and more data comes in around cybersecurity. That's a huge amount of data. And there's a number of vertical industries on the screen here that are, relatively dealing with large data volumes anyway, even prior to all of this uh, new stuff emerging. And so companies just can't afford to move it all uh, and still keep operating when they've got to deliver some of these obligations in a pretty short time frame. So what you end up with when you say to yourself, well, what exactly is the cost of data engineering on the cloud, given the fact that there's a lot more data engineers and they're still growing as data mesh gets implemented around organizations. There's multiple tools out there. People are subscribing to different tools. Every tool's got its own um, units for pricing. There's more and more pipeline dependencies. Um, and you kind of ask yourself the question, has anybody got any idea what exactly the invoice is going to look like at the end of the month for data engineering? And I would argue the case that probably not. And and then you add into the mix data volumes on top. If all of these people are then getting involved in hyperscale data volumes, and you begin to realize, geez, I mean, how big is this going to be? It's a complete unknown as far as I can see.
So
I don't.
you're saying the state of the industry now is tens of billions of dollars are being spent on kind of cloud resources, and yet the kind of users of this, the people that create this usage demand that is what determines the billing level, they don't really know, what they're spending. And they're trying to solve a business problem. They don't really have a sense of, well, that's a $10,000 query. If you want to run that, I mean, if that's $1 billion customer, yeah, run it. But if it's like a $100, task, people don't even, you're saying people don't even really know the cost implications of what they're doing.
I can't see how they do know, because if you've got different people using, as we said, lots of different tools, there's more and more data engineers emerging. You've got pipelines,
Yeah.
pipeline dependencies across multiple tools with greater and greater data volumes, and no easy way to consolidate and see that cost. I don't know how a CFO knows what the
Right.
what the cost is going to be at all.
Short of getting the bill and freaking out,
Yeah, like it kind of shows
it's
you
too
on
late.
the screen here. Yeah, they're kind of blind, if you like, to the cost, as far as I'm concerned. Yes.
Yeah. And
Yeah.
that was one, even, cloud has a lot of advantages, but one of the advantages
Oh,
of kind of
absolutely. Yeah.
traditional is, if I'm going to buy this cluster and this software to solve this data analysis problem, I know how much it costs, and for the next 3, 4, 5 years, that's what, I got it, I got that cost I'm carrying to solve that problem. Whereas with cloud, you just don't even know.
No, I can't see it. If if this unfolds the way it is unfolding, and certainly enough of my customers, I do enough consulting to know that that's absolutely the case, because
Yeah.
business unit autonomy is now spending a fair percentage of the of budget on their own technologies. There's no question that the complexity around all of this is growing, and as it does, people become increasingly more blind to the overall cost of the whole thing end to end.
Yeah.
And so then you might say, well, what kind of requirements are there to engineer data at hyperscale? And there's no question, the advantage from a business to be able to process data and make decisions on it, have richer data sources, is absolutely, not, we're not questioning that. The advantages of being able to get data, absolutely super important. But given that degree of complexity, what kind of requirements do you need? Because, clearly we are now trying to engineer data from an increasingly spread out data estate, which is scattered across multiple different data stores, um, while in truly hybrid environment, um, multiple clouds on premises, the edge, and SaaS applications. And so we need some kind of platform to be able to deal with that. And within that platform, I need some kind of ability to still allow divide and conquer amongst data engineers, to still allow more and more data engineers to emerge, but to try and provide a common platform by which they can go about doing this so people are aware of who's building what, and that they can, build transformational pipelines, ingest data, build transformational pipelines, build data products that I mentioned before, and use them for both, classic multidimensional analysis in a data warehousing environment and feature engineering and data science, and bring those workloads together to be able to do that. And on the ingestion side, I need, when I'm dealing with these kind of high scale data volumes, I need the ability to ingest in parallel from a number of places. I need the ability to do that, without necessarily having a separate ETL tool involved. I need to be able to compact those files, separate the ingestion workload from any query workloads that are going on, and be able to do scalable data transformation during the ingestion, so that by the time you land it, you've already got it in some kind of queryable format, maybe even indexed, in order to be able to not only help the ETL performance if you're going to then work on it, but also to help query performance as well. And from a storage perspective, I need to be able to compress that data, because as I said, volumes are getting increasingly bigger. I need to be able to partition the data in flight in order to facilitate parallelism, cluster data to minimize the IOs, and do columnar formats so that we only pull out the columns that we need, in order to be able to query and transform or form the overall data. So that gives us that kind of performance capability. But as you get into more and more hyperscale requirements, there's no question, that we start to move away from what I would call general purpose databases towards what I would call, more optimized databases. That matters whether you're moving in a transaction processing world or whether you're moving in an analytical world. And hyperscale platforms can be these optimized databases, which naturally are built from the ground up to be able to satisfy that kind of workload. And so what we want here is an alternative pricing model to pay as you use, and being blind to what the invoice is going to be. We need some ability to be able to filter out data quickly, and have aggregations, at the IO layer. We need massively parallel capabilities within that platform. In order to be able to engineer data and query data, we need the ability to scale up, lookups and upserts and things like indexing, and be able to to process extreme volumes and manage the workloads going on, and of course, as that data comes in, to be able to scale the right processing. And I do believe that there is a point, when we get into these extreme data volumes, where specialized exploitation of hardware to engineer extreme data volumes can make a significant difference, especially when companies are under pressure to deliver workloads in a short term, like regulatory reporting and stuff like that. They got to get that job done, and be able to do that without having to have to duplicate data as well. We want to be able to do that without having to duplicate data from a recovery perspective, because the volumes are so large. So I guess in conclusion, then, I guess what I'm saying is the volumes are increasing exponentially. The number of data sources are increasing exponentially. We've already got democratization of data engineering underway, with more and more data engineers emerging. Companies can't quantify the cost of data engineering because people are using multiple different tools. There's no way to share metadata across them, so people are unaware who's building what. And as a result, there's reinvention going on. There's increased complexity with pipeline dependencies, and putting a figure on what's the cost of data engineering is just not easily doable at all. And so as larger data volumes get added into the mix as well, especially if those unit pricing is done on the amount of data that you're processing, you could be extremely costly at the end of the month from a data engineering perspective. And so we need some kind of solution around that that's going to be able to reduce cost and put this into a quantifiable and understandable figure for that, so that people can manage their expectations, deliver on their requirement to be more agile, still allow democratization of data engineering, but do it at hyperscale in a manageable way. And so with that, I'll like say thank you, and I'll stop sharing and hand back to Chris. I'm just trying to see.
Thanks, Mike. That's super insightful research. One of the cool things about Ocient is our focus is exclusively the largest data analyzing organizations in the world. So we get to know them and understand what they're doing. And we built a hyperscale data warehouse with machine learning and AI and geospatial at hyperscale with these challenges in mind. But we're talking about ETL today. So in particular, we also had to build a hyperscale ETL capability. And, that uses our compute adjacent storage architecture, which is super cool, but we're going to talk about ETL. And, one of the things about that isn't just the technology, which is, super parallel and scales to forever, but the usage model is as much of it, that really makes it interesting. Because, if you're loading 10 terabytes a day of data and you're paying on usage, that becomes an extraordinarily uncomfortable bill at the end of the quarter. So we found one of the capabilities is kind of capacity-based pricing model versus a usage-based pricing model, so that for these hyperscale level systems, that really ends up being much more cost-effective for them. I'd like to bring in Joe Jablonski, our Chief Product Officer, to add maybe a couple more thoughts on this, and he's probably got a question or two for you as well.
Yeah, Mike, thank you. I think the first thing is to really start to define what hyperscale looks like in my mind in terms of quantifiable numbers. And at Ocient, the way we look at hyperscale, especially on the ETL side, is really number of events you're handling per second. So when you start coming into hyperscale, you start seeing 100,000, really up to like maybe 25 million a second on some of the larger size applications. And when you really think about, you're handling 25 million events per second, and you really have to clean, filter, enrich, index, and then load that data at 25 million events per second, it's non-trivial. And it really requires special systems and new techniques to be able to do this. And we see the shift, as you talked about, with your, you sort of said the citizen data engineers and the creation of data products. I completely agree with you. And it shifts the burden. Over the years, we've seen the data producers really generate data lakes over the years. And the data lake was really filled with what I'll almost call the data dumping ground, right? That we've seen over the years. And it really meant your data wasn't in a clean shape. It was generally unformatted, might have been in JSON format. And it was on the burden of the person doing the analysis to do the cleansing in the engineering. And this often required that cleansing, that filtering, that loading to be absorbed by every consumer. And really, I think what the data product design and the data mesh design that you're suggesting really means moving that to the data producer, and moving that load onto the producer. And it really is, and it's all that work that generates that. And that's the ETL on that's non-trivial, that Ocient really specializes in doing the ETL on that at that scale. But in addition, what you see is you start seeing that 10 million records per second quickly adds up to hundreds of terabytes, to petabytes, to hundreds of petabytes of data when you start keeping that around for a year. And then storing that data and then analyzing that data effectively really becomes incredibly expensive when you use traditional systems. So what Ocient, what we've done is we've really focused on the hyperscale problem. So from the ingest, as I've talked about, where we can scale up to 25 million records per second, to really the analysis, where we can store 10, 100 petabytes of data and run interactive query times. And the reason we can do this is what we see on the screen right here, is our compute adjacent storage architecture. So really what this is focusing on is the use of modern hardware. And modern hardware comes in a few forms, primarily in the form of NVMe drives and non-volatile memory express drives. Modern NVMe drives are capable of over a million random seeks per second per drive, and are capable of over 100 gigabits per second per drive. If you put between 12 and 24 of these into a server, you can get 2 terabits per second scan rates off your I/O subsystem. You can get 24 million random seeks per second off the drives. It's really these structures and using the data structures and writing your query engine to use that hardware that makes Ocient efficient. And the net effect for the user is that we can dramatically lower the cost per query versus traditional systems. Primarily systems that are relying on spinning disks and remote storage, like S3 type storage. And what that does is just dramatically lower the cost of these data products.
Yeah, I mean, I think from my point of view that people need to kind of know what's this going to look like in terms of overall cost. I think, as Chris said, I mean, the whole usage-based pricing around this at hyperscale, especially at the volumes that you just mentioned, Joe, is just, and the fact that potentially so many people building pipelines with so many different tools, I just think that there's no, there's just no easy way to A, figure out the price, and B, add into the mix the volumes that you're talking about, and on a usage-based pricing model, it could be off the scale, and so for that reason, there's got to be an alternative way around it. And so certainly what you're talking about here seems to make a lot of sense for those kind of hyperscale problems.
Yeah, I think, Mike, one of the most important things, and people don't realize it, is systems can be 100 times more efficient. With modern hardware, with modern systems at hyperscale, it's fundamentally possible. So what does that mean? Picking the right system just becomes essential. If you pick the wrong system for the job, it could be 100 times more expensive. And it just becomes essential for picking the right platform.
Yeah, there's a question in the chat. For Mike, any suggestions for CFOs that are trying to manage all this? How can they partner with CDOs, CTOs, CIOs to manage cost with all the data complexity you've talked about?
Well, I mean, I think CFOs are totally blind. I mean, I think that's the case because they're not exposed to what's necessarily going on across the enterprise around data engineering. CDOs are far more aware, I suppose, of multiple projects that may be potentially going on, and I think the partnership between CDOs and CFOs matters a lot. But even so, it's not just a human problem that's needed to be fixed here in order to solve this. I mean, there's a technology needed to be able to solve it as well, and to move, at the kind of volumes that Joe was talking about, to move to a different approach to a usage-oriented pricing model, at this kind of volume is could potentially be quite scary as to what the overall pricing could be. So I do agree, yes, that but I also think that CFOs need to have a matrix going on, not just a CDO in place. I think they need to have a kind of communication going on with the heads of different business data domains in order to be able to make sure they're not missing anything.
Yeah, I have a follow-up on that, Mike. But let me first say, if there's any questions, just put them in the LinkedIn chat. We'll try to get to them. I'd also like to note that I so far don't see anyone in the chat with an example of a new version that makes less data than the old version of anything. But so kind of following up on that, like how do CFOs and organizations manage these usage-based costs? I wonder, one thing we're seeing in customers is they want the cloud benefits of, kind of outsourcing a lot of this IT infrastructure stuff and kind of the ability to have, capability grow because it's a giant cloud provider and things like that. But at the same time, they want, not usage-based pricing, but capacity-based pricing. And so, we have a large customer that we just worked with that had signed a giant, $1 billion commit with one of the big cloud providers. So we ended up deploying on the cloud. So they got the benefit of a huge, expert cloud provider kind of at the infrastructure level and the server level on down. But then the way they purchase our software, and we would sell it either way, was capacity based, like based on the number of cores. And they can kind of run as much as they want. They can fill those cores, 24 hours a day if they want, of cores of analysis capability. So I wonder, I guess a question for you, do you think, because it's like the first generation of all the cloud stuff came out where the software is all usage-based price. Do you think you're going to see in the future maybe a return, it's still cloud, but a return to more capacity-based pricing as a way of managing these costs?
At hyperscale, I would think so, yes, because there's got to be, they've got to get their head around the thing. You can't just have, especially in a tight economy, you can't, as it is now. I mean, you just can't have an unknown here. I mean, everyone's watching in a tight economy. Businesses are, tightening their belts, and no question about it that CFOs are on top of that, and at the same time, they're not trying to stifle innovation around data and analytics. I mean, we all, everybody wants to become data driven. There's that's not in doubt, but I do think it is definitely the case that without some kind of unless you've got a FinOps solution, if you like, that has the ability to cast its eye across a ton of different tools, all executing pipelines at very high frequencies on huge amounts of data, I can't see how they can even get remotely close necessarily to what that figure may be. And I think absolutely, as I said already, not also possible to move all your data to the cloud up front. People have to still operate. They've got a ton of data still on premises, and therefore need to deliver on whether it's regulatory obligations or other business problems. They have to deliver on them, and can't wait to move all data to the cloud. So I do believe most organizations are in a hybrid state, and do want a capacity. I think there's definitely room, absolutely, for a capacity-based pricing model at hyperscale in the data engineering capacity. No question about that. Especially now that we're seeing. Well, let's face it. We've broken the logjam. The logjam was a bottleneck centralized IT data engineering. We've got an explosion of data engineers emerging within organizations. And the general consensus is we're going to upskill a whole lot of folks around the organization to do data engineering. So that result is over the next few years, we're going to see a ton of growth in the data engineering workloads emerging within enterprises. And as a result of that, this cost can go a lot higher in a world where they can't get their head around what the cost is now, never mind what it's going to be going forward. So I absolutely believe there's opportunity for capacity-based pricing, because it helps manage expectations and allows people to know what that cost is going to be.
Yeah, I got a related question I want to ask Joe, and it's based on the assumption, which I think is really how it works, is that vendors have constraints in their ability to price things to their customers, and you can only go so far as procurement by like just trying to negotiate lower costs from an IT vendor. So what you really want to do is to figure out like what is a structural way that it'll be more efficient, because then you're going to get better pricing. And so my question for you, Joe, is if you're looking at like a hyperscale ETL or hyperscale data warehouse, what are the structural things you look for technically so that that vendor can really give you something cost effective, because it's cost efficient for them too. So what are the technical things that really make a system more cost efficient at hyperscale?
Yeah, it's a really great question, and it really boils down to picking the right tool for the job. There's many different tools out there, and really the category of really hyperscale analytics boils down to a few characteristics. I think the first one is compute adjacent storage. I think when you start seeing compute adjacent storage, and really we call it, size on disk, and really focusing for the size on disk. When you start talking about 10 petabytes level of data, it's how much storage are you really taking up? Focusing on compression, focusing on things like erasure encoding for storage on disk, focusing on really different compression techniques. And then really, how are you using the hardware? Are you focused on using NVMe drives? Are you focused on using high core count processors really well? Are you focused on using 100 gigabit networks and really utilizing 100 gigabit networks? The price of the commodity hardware is coming down to the point, but utilizing all this is not easy. So focusing on utilizing pure commodity hardware, and then really staying away from some more expensive type hardware platforms. GPUs, FPGAs, things like that are really more expensive in nature. So focusing on commodity hardware platforms is also, I think, a big driving force of this. And then I think at hyperscale, what you see is the need to index data. Many platforms have gone away from indexing data. And so at hyperscale, indexing is just essential, because you can't, no matter how fast you are, doing a full table scan at 100 petabytes just doesn't make sense. So you just have to index data properly.
Yeah, and it doesn't make sense from not only a performance point of view, but a cost point of view. If you hit the enter key on a 10 trillion row full table scan, it costs real money. And you start thinking about like how much are you asking that CPU to do, how much data you got to flow through your DRAM interface, and like there's a cost to that. And whereas it's not just faster, but if you can index it one time and then do 1,000 operations, it saves a lot of money.
Chris, just one more thing I think that's just essential is that really a great workload management system is just essential when you're running hyperscale queries.
Yeah.
You talk about value of queries within an organization. When you build a data product, you have some consumers that are just getting a lot more value out of the data, and you have to prioritize those users, especially when you've constrained on your system size. A very robust workload management system is just essential.
Yeah. All right, Mike, a question from the audience for you, which is, which industry use cases do you see where customers really have this need for 500 or cores more of analysis? Where are you seeing that in terms of what industries, what use cases, what verticals are really at this hyperscale?
Well, I think some of the verticals that I talked about in the presentation. I mean, you can definitely see telcos. You can definitely see government, AdTech, manufacturing, smart consumer goods in particular. The amount of sensor data pouring in is just ridiculous. Even off of industrial IoT, it's ridiculous. So when you get into large volume consumer goods manufacturing, never mind. You got the goods data coming in as well as the industrial data coming in. You can say, as I already mentioned, automotive industry, insurance now also, getting and tapping into all of that, to give them more insights, and of course government, so there's I think a lot of organizations moving in this direction, and as I guess to add to your point, Chris, I don't think I've ever seen data volumes going down in my 40 years, right? And if anything, this is, we are now skyrocketing, at a level way beyond I've ever seen before, and it's exponential. It's still growing, and more data sources keep popping up, and more as an intermediary data marketplaces keep popping up with more and more data that people think, oh my God, I want that, I want that, I want that, and so the chances are that we're just going to keep seeing more of it, and of course people are, especially in analytics, very interested in historical analysis. So, we're not going to just let it go immediately. We're going to hang on to it and want to go back, reanalyze it over time, see what the implications there are. So, it's a growing historical set of data that companies are interested in and will continue to be so going forward.
Yeah. I mean, kind of related to that, provocative but not really provocative statement of how everything's new version makes more data than the old version is, I think we have a combined greater than a person century of industry experience here among the three of us. And I can't think also of an example where a new technology comes out that makes anything, compute, storage, networking, more price performant. And the way the industry uses it is to do about the same amount of whatever they were doing before and save the money. I can't think of an example, because always what industry does when the hard drive gets bigger, the CPU gets faster, is they just do a bunch more. And that, like, these industries just keep growing and growing, even though the price performance has been getting orders of magnitude better, over the course of the past 50 years. I mean, everything's a million or a billion times more price performant. But it's not like the industry just saves the money and just does less of it at lower price. They just do 10 billion times as much. Now the industry's giant. One thing I don't think we could get away with delivering on this webinar unless we provide some kind of like eye-popping statistics. So Joe, one thing that I just, quickly curious about, do you have any stats on like how much data the average car makes these days or something like that? Like, I mean, the average person on the planet, how much data is generated, per day? Can you leave us with something to, take home to our families?
I think,
and impress them with the complexity of the work that we all do in this industry.
I'll answer the question about a car, and this is a publicly available stat, is each hour a car drives, it produces 25 gigabytes per hour that the car is on the road.
Exactly.
And when you talk about 25 gigabytes as an individual, that doesn't seem like that much data. But when you talk about the 50 million cars that might be on a road during rush hour every day, and multiply that by the 25 gigabytes being generated by that vehicle, that's the sort of hyperscale load that vehicle companies are up against.
That's just in the U.S., by the way. There's more than 50 million cars out there.
Oh, I know. There's like a billion on the planet.
You're right. Whatever that number is, but it's the staggering flow of data in. When you start seeing, that was vehicles, content delivery networks. When you're trying to understand what's going on a content delivery network, in the latest software patch just gets published, the content delivery network, you're going to be spiking up to 100 million download events per second that you have to track, that you have to store, that you have to filter, that you have to enrich, index, and then prepare that so customers can bill on. And it's those telco networks. It's the optimization of video on demand platforms. It's not uncommon for a video on demand platform for a major telco to produce 100 terabytes of log data every night that needs to get analyzed to find the optimal way to deliver video on demand, where are my bottlenecks occurring in my network, and then the ability to really deeply ingest that, but then not only analyze and then run machine learning on top of that is really what, and one of the comments in the chat was about really getting value out of that is just so critical, and then making that value equation so it's profitable. And so the two sides of the profit are not only the value, but the cost structure that you can load 100 terabytes and run machine learning on that every day. So it's 100 terabytes a day that you have to load. So anyways, if those are the sorts of applications that are eye-popping at the end of the day, what hyperscale loading, transformation, and then machine learning and querying happens at that scale.
Yeah, and I know that, like, if you were to add up all that car data, for example, it's like a quintillion rows in a table, if you collect it all. And yes, I know people don't load the whole thing. They're going to do all kinds of clever stuff to reduce it by 1,000, 3 orders of magnitude. But, a quintillion divided by 1,000 is still a quadrillion. And a quadrillion is still a ridiculous number. So yeah, you're going to do all that stuff, but you still end up, in the land of, it's just ridiculous. I was at one of the telcos, the U.S. telcos, and I won't name names, the day that Call of Duty, the new version of Call of Duty came out, and it broke the internet. I mean, it just, like, in so many ways, it broke the internet. They recovered and they dealt with it, but yeah, I mean, that stuff still happens where not only do you have these, like, daily flows of cars and all this stuff, but then every once in a while you get these events, like, boom, Call of Duty hits, internet breaks. Because it wasn't just the flow of data, it was all this metadata about the network that's really important for all kinds of reasons, billing and cost and compliance and capacity planning and whatever. And it was a level of activity on the internet that it couldn't measure itself. It couldn't record what it was doing, for about 4 hours or 8 hours, whatever that was. The final point, we have just 3 minutes left. Maybe I'll just throw out a teaser for a next, webinar that we might want to have is, buried in all this complexity and scale that we're talking about is it's becoming at hyperscale just really impractical to expect, a small amount of resources to make these things work. I mean, it's just, you can't just hand over these hyperscale building blocks and say, yeah, I'm going to Lego this together this afternoon and we're going to have something that deals with a quadrillion events from, 50 million cars. It really challenges IT organizations because the solution, getting to like a business result requires a solution. And it's just years and years of, expertise and skill that are required. And, maybe we'll talk about that next time, about kind of the solutions implications of hyperscale. But with that, since we're coming up on time, I'm going to wrap us up. Mike and Joe, thank you so much for joining us today. That was a super interesting conversation. We've recorded this, so we're going to share it. If anybody wants to, dig in. If you found today's conversation interesting and engaging, we invite you to reach out to learn more or request a demo via our LinkedIn page or at Ocient.com. We'd love to stay in touch, so please like our page on LinkedIn or Twitter, or subscribe to our YouTube channel. Get in touch via our website. And if we can be of any service in reducing your ETL and data warehousing costs at scale, let us know. That's it for our first LinkedIn Live. Mike, Joe, thank you for joining. That was fun. And always enjoyed talking with you guys because I learned so much. And with that, we'll see you all later.